Hello again. In the previous video, we started seeing how if we want to create code that is really generic, we need to introduce some free parameters for things like the test size of our splits or the random states and things like that. Now we're going to apply those ideas to create a new Kedro pipeline that is going to combine normal datasets as we've seen before with parameters that we can change whenever we like. So let's get to the code. Now, I did this test with parameters.yaml, which is the base parameters file that was created, but I'm not going to need this anymore, so I'm going to delete that. And what I'm going to do now is create a new Kedro pipeline that's going to contain the training of my model. So first, remember that I have one pipeline already created, which is called data processing. Now it's going to show next to default. And I want to create another one. So I'm going to do Kedro pipeline create data science. And again, this is going to create a number of files for me. So you see there's inside pipelines, the data science one with nodes and pipeline. And I have a parameters data science here. I'm going to use this file now to add the parameters that I will need with my function. Now, if I open this, you see that this is mostly empty. And now I'm going to follow the instructions of the documentation. So if you see here, we had a root key called model options, and this is going to contain the test size, the random state, and the features. So let's go. Model options. This is going to contain the test size, which is 0.2, the random state, which is going to be 3, and then my list of features. I'm going to copy paste them from here. Now, we didn't talk about the random state yet. What is this exactly? Well, remember that most of the scikit-learn models contain some sort of randomness into them. So we cannot avoid that randomness, but we can control how it is manifested in the code. For this, we need to set the random state, which is the seed of the random generator algorithm. And by controlling that, we can at least assure that if we run the same training twice, the results are going to be random, but are going to be consistent. Now, I have my parameters here. It's the time to create the nodes. So I'm going to go to pipelines, data science, node.py. And again, I'm going to copy paste some code from the notebook. So this should be import pandas as PD. And I will also need from scikit-learn model selection import train test splits. And finally, from scikit-learn metrics import R2 score. Now, I have to think about how do I want to design my pipeline. And in this case, I will want to have 3 nodes. One to split the data, another one to train the model, and a third one to evaluate the model. So let's get going. I'm going to copy the function that I was just creating before, which is this split data function here. And just for safety purposes, I'm going to import the typing module of Python, and I'm going to use these parameters here. This is going to be a dictionary, and it's going to return a tuple. Now, this is going to be the function of my first node. Let's write the other ones as well. I'm going to have another function called train model. And if you see from the documentation, this is going to contain only the part of the code that trains the model itself. So we're going to receive the training data, only the feature matrix, and the target vector as well in the form of a panda series. And it's going to return a scikit-learn model. So if we do xtrain, which is pandas data frame, and y train, which is a pandas series. And this is going to return a scikit-learn model. We're not going to care about the base class of the models at the moment. So this will be from scikit-learn linear model, import linear regression. And now this is going to be my model. I'm going to fit the model with x and y, and I'm going to return the trained model itself. Now we need one more function, which is the one that is going to evaluate the model against the tensed data. So again, if we see here, this function is going to be called evaluate model, and it's going to receive the model, which we're calling now the regressor, the test data, the feature matrix part, and the target vector part. So let's do that. Evaluate model with the regressor, which is a linear regression, the test data, which is a pandas data frame, and a pandas series. And what this is going to do is to call the R2 score with the test data and the predicted data, which comes from evaluating the regressor. So I will do regressor.predict with xtest, and I will store this result into a score variable, and then I can add some extra code to actually display this score somewhere. For this, for consistency with the tutorial, I'm going to use the logging module. So I'm going to import logging from the standard library, and I'm going to save the logger. So this will be get logger, and I can use this logger object to perform any logging calls that I need. So now this is going to be logger, for example, .info, and I'm going to use the same message from the documentation. So this is going to be model has a coefficient R2 of something in this test data. So I add this part here and I'm done. Now I have my nodes, and the last step is to assemble them into the pipeline. So I'm going to go to the pipeline here, just so I don't lose track of anything. Let me open both files. I'm going to import from nodes my evaluate model, train model, and split data. And I will add 3 nodes here. I will also need the node function here. And this will be 1, 2, and 3 nodes. So the first one is going to be split the data. The inputs of that are going to be my model input data, and I will need some parameters as well. So if you remember, I could access those parameters by using the params prefix, and then remember that the parameters that I created were called model options. Now the outputs of this are going to be all the arrays that I'm going to need later. So for consistency, again with the documentation, let's go and see how is the pipeline definition. And we're going to call them just xtrain, xtest, ytrain, and ytest. So this will be xtrain, xtest, ytrain, and ytest. Now that was my first node. Let's continue adding the other ones. The second one will be train model. The inputs of that will be my x train and my y train. And the outputs of that, again for consistency with the docs, we're going to call them regressor. Now finally, the last node is going to be evaluate model. The inputs of that are going to be the regressor that I'm producing in the other one, and the X test and Y test data that come from the first node. Finally, this has no outputs, so I can have this with the value none, and that's it. Now, if I didn't do any mistake, we should have in our Kedro registry a new pipeline called data science. Let's give it a couple of seconds to finish. And now I should be able to run only the data science pipeline. So I see here that I made a mistake. It's not model input data, but actually model input table. So I'm going to change that here, and I'm going to try that again. And now everything works. So as you can see, the different nodes were being executed. All the intermediate results are memory datasets, so nothing is getting saved to disk. And I see here a line from my own logs which says model has a coefficient R2 of 0.396 on the test data. Okay, so we got to a very interesting point. Now we have our data science pipeline. The inputs of that are parameterized thanks to Kedro parameters, which means that I can iterate on that later on. And I'm in a very good position to keep improving this model and try to improve the accuracy. More on that in the next video.